Hello, welcome to Business Statistics. In this lecture, I will discuss about measure of location or central tendency. For any given data set, we are interested in knowing a central value around which most of the data points lie. So this central value can be mean, median, mode, or trimmed mean. So first discuss mean. You might know mean is average. So for population, mean is represented by mu, which is sum of all the numbers in a population divided by the total elements in a population. For sample, the mean is represented by x bar, which is sum of all the numbers in a sample divided by the number of elements in a sample. So this is a simple definition. Let's take a data set and calculate the average. Suppose our data set is 8, 10, 12, 4, 7, 6, 19, 22, 14, 12. So if you see the number of data points in this data set is around 10. So we have, if we treat this as a sample, then we put small n is 10. If we treat this data set as a population, we can say capital N is equal to 10. So calculation of average is simple. If we consider it as population, we write mu. If we consider it as a sample, we write x bar. So this is equal to 8 plus 10 plus 12 plus 4 plus 7 plus 6 plus 19 plus 22 plus 14 plus 12 divided by 10. So this will give us an average or mean of 11.4. So the next concept which I want to discuss is median. So median is middle value. So that is, it divides a data set into two halves. So for median, if we have a data set whose size is odd, so if we have odd number data set, then the median would be n plus 1 divided by 2 the term. So this is term. So if n is even, then median is the average of n by 2 and n by 2 plus 1th term. So we can kind of I will explain it in more detail, the median by taking a data set. So let me see. So if we have a data set, let's take the same one which we took for mean, 8, 10, 12, 4, 7, 6, 19, 22, 14 and 12. So the first step to calculate median is to arrange them in ascending order. So we have to arrange the data in ascending order. So let's arrange this in ascending order. So our ascending order would be 4, 6, 7, 8, 10, 12, 12, 14, 19 and 22. So our size is, the size of the data set is, again, n is equal to 10, which is an even number. So if it is even, we will take the average of n by 2 tooth term and n by 2 plus 1 the terms average. So we are taking average. So n by 2 means 10 divided by 2, which is 5. So we will go here and look for our fifth term. So this is 1, 2, 3, 4, and our fifth term is 10. And then next, n by 2 plus 1 would be 10 by 2 plus 1, which is 5 plus 1, sixth term. So our sixth term would be 12. So we have to take the average of both of them. So the average of these two would be 10 plus 12 divided by 2, which is 22 divided by 2, 11. So the other case would be if our data set is odd. So I will generate another data set, for example 5, 4, 2, 9, 7. To calculate median, the first step is to arrange them in ascending order. So the ascending order would be 2, 4, 5, 7, 9. So our n would be 5 because we have 5 data points. So if it is odd, we will take n by n plus 1 divided by tooth term will be our median. So that is 5 plus 1 divided by 2, 6 divided by 2, that's 3. So the third term would be our median. So it makes sense, it divides the entire data set into two halves, or median is a middle value. So if you see, we have 2 on this side, 2 on this side, so the median is 5. So this is median. Here in even, 11 is our median. The next topic which I will discuss is mode. So mode is most frequent. So whichever number is most frequent, it is called mode. So if we take an example of our data set, one of the data set we took was 8, 10, 12, 4, 7, 6, 19, 22, 14, 12. So we are looking for most frequent number. If we see 8, 8 is not repeated anywhere. 10, it's not repeated. 12, we have 12, 12 here, and the other 12 is here. So that's 2 12s. 4, it's not repeated. 7, it's not repeated. 6, it's not repeated. 19, it's not repeated. 22, it's not repeated. 14, it's not repeated. So since we have 12 repeated twice, which is the highest, which is most frequent, our mode for this data set would be 12. So another example of mode, suppose we have 6, 6, 7, 6, 8, 9, 7, 1, 7. So the mode for this is, if you see, 6 is repeated 3 times, 7 is repeated 3 times. So here we have 6 repeated 3 times and 7 repeated 3 times. So our mode would be 6 and 7. So this is called bimodal because we have two modes. So I will take another example, which is 6, 6, 7. So this is 7, 6, 8, 9, 7, 1 7 3 1 2 1. So here if we see 6 is repeated 3 times, 7 is repeated 3 times, 1 is repeated 3 times. So our mode would be 1 6 and 7. So this situation would be called multimodal. So this is mode is most frequent. So the next topic I will talk about is trimmed mean. So this is used when we wanted to trim the extreme values or outliers. So we are trying to trim extreme values. So the way we do it is we arrange our data set in ascending order. And then we will calculate how much we wanted to trim. So that is given by this formula. So where P represents percentage of trim, and then N represents the size of the data set. So this is trim. Suppose we have a data set. Again, we will use the same data set which we were using, 8. It's 10, 12, 4, 7, 6, 19, 22, 14, 12. So our size of the data set will be again 3, 6, 9, 10. So that would be 10. So the first step is to arrange it in an ascending order. So I'm going to arrange this in an ascending order, which is 4, 6, 7, 8, 10, 12, 12, 14, 19, 22. And then we will use this formula to calculate how much to trim. So a percentage will be given, so this will be given to you. So if I wanted to trim by 10%, so the formula would be 10 divided by 100 multiplied by the size of the data set is 10, so this is going to give me 1. So I have to trim one data point from both sides. So what I would do is I would trim this and this, and then I will take the average of the remaining data set. So this would be 6 plus 7 plus 8 plus 10 plus 12 plus 12 plus 14 plus 19 divided by, so now we are left with 8, so we will divide it by 8. So that will give us a trimmed mean of 11. So this is trimmed mean. So the next concept which I will discuss is relationship between mean, median and mode. So in this I will be talking about relationship between mean, median, mode. So out of these three, mean is very sensitive to extreme values, median is a little bit sensitive to extreme values, and mode is not at all sensitive to extreme values. So if I have a normal distribution or a symmetrical curve or a bell-shaped curve, so this is how a bell-shaped curve looks. This can be obtained from histogram. So it's a symmetrical curve, or a so it's a symmetrical curve or a bell shaped curve, or we can call it as normal. So in this case, the mean median mode will all lie at the center. So if we have a different curve which is skewed towards right, so this is if we have a, a tail, a long tail on the right side, it's called right skewed. So in this case, mostly mode will be there. However, median will be dragged towards right. So this is my median, and then mean will be dragged towards right. So that means mean will be greater than median will be greater than mode. So our third case, we will have a curve which is left skewed. So we have a long tail on the left side. So this is left skewed. So in this case, our mean and median will be dragged towards left. So mode will be here, and then we have median, and mean will be dragged towards left. So in this case, mode will be greater than median which will be greater than mean. So that's how the relationship between mean, median and mode exists. This concludes our lecture on measure of location or central tendency. Thank you.